Welcome to the exciting conclusion, part 3 of section 9.2, hypothesis testing and confidence intervals for two population means with independent samples. So by way of review, when we do a confidence interval for two samples, we do one confidence interval, but that confidence interval is for the difference in the two means, and we're taking independent samples right now. So let's take a look at this. If we have two means and find the difference, the subtraction of them, we're going to do mu1 minus mu2. If mu1 minus mu2 is positive, the only way that can happen when I subtract and get a positive number is if the first number is higher than the second one. So if mu1 minus mu2 is positive, then mu1 is greater than mu2. We might use the simple greater than symbol. Similarly, if mu1 minus mu2 is negative, then mu1 is less than mu2, and we'd use the less than symbol. So let's take a example here. Don is comparing the fat content of healthy snack trail mix with that of overland trail bars. A random sample of 12 28-gram servings of healthy snack mix had a mean fat content of 6.8 grams and a standard deviation of 1.2 grams. An independent random sample of 10 28-gram servings of overland trail bars had a mean fat content of 4.2 grams with standard deviation 1.6 grams. Given that the fat content for each snack is normally distributed, find and interpret a 95% confidence interval for the difference of the two population means. So first off, we do a requirement check. So just by the way the problem gave it to me, I'm going to let group 1 be healthy snack fat content and group 2 be overland trail bar fat content. Okay, and so overland trail bar. Okay, so we don't know anything about the population standard deviations. So we're going to write sigma 1, sigma 2 are unknown. Okay, did we have independent samples? And the problem tells us, yes, they were. There was no relationship between the data values in one sample and the other. Okay, so 2 down. Were the samples random? Yep, we randomly picked the bars for inclusion in the sample. And lastly, we only had 12 of the first one and 10 of the second one, but we're saved by the fact that we are normally distributed on each snack. So we'll write normally distributed on both. So this tells me that our techniques are probably going to be pretty good here. So let's keep going. Since healthy snack was the first sample, our average fat content from that was 6.8 grams, and our standard deviation was 1.2 grams, and we had a sample of 12. For the second group, the overland trail bars, the average fat content was 4.2 grams with a standard deviation of 1.6 grams and, standard deviation of 1.6 grams, and we had a sample size of 10. Now, we could go through all the formulas, but I'm just going to cut to the chase and get some help from my technology. I'm going to use my calculator here. So we'll turn it on and see if we can move that so we don't have the glare. We're going to go to our stats menu. Last video, we did a 2-sample t-test, but this is not a test anymore. This is a confidence interval. So we need to scroll down until we can find, for me, it's option 0, a 2-samp t-interval. We took 2 samples, we're doing the t-distribution, and we're doing a confidence interval, not a hypothesis test. Now, it'll default to what I last did with anything with 2-sample t. So I'm going to go over to stats, not the data from the SpongeBob problem. And so let's put in our important stuff. So X1 bar was 6.8 with a sample standard deviation of 1.2. And we had 12. X2 bar was 4.2 with a standard deviation of 1.6 on a sample size of 10. And what was our confidence level? Our confidence level was 95%, a very common one. Again, we're going to go with the camp that says, let's not pool our standard deviations, and let's hit calculate. Write down what we get here, and then interpret him in real world terms. It'll take a second to think. So our 2SAMP T int comes back with 1.30 to 3.90, and we have 16 degrees of freedom. Let's go ahead and write that down. So 2SAMP T int, because it's a confidence interval, and we've got 1.30 to 3.90, and notice that we had degrees of freedom was 16.46. Okay. All right, so let's write it in real world terms. Now, since we have two samples that we are talking about here, and this is not a confidence interval for one sample or the other, but for their difference, we're going to need two parts to our conclusion. So first off, let's start off with we are 95% confident that the population mean difference in fat content of, and then who was first? Healthy Snack and Overland Trail Bars, because they were second, is between 1.30 grams and 3.90 grams. Okay, and if we were to take a look at a number line here, notice that the confidence interval for the difference is all on one side of 0. So from 1.30 to 3.90. Uh-oh, if the entire difference is positive, that means then, remembering earlier, that mu1 must be greater than mu2. So we're actually going to take and do that second step here and say, because the confidence interval had only positive values, we are 95% confident that the average fat content of Healthy Snack is higher than for Overland Trail Bars. Does that make sense? So just to do a what if our confidence interval had come all the way down here, then we would see that our confidence interval was entirely negative. And if the confidence interval is entirely negative, then we have strong evidence that mu1 is less than mu2. Okay. And it would be the other way around. And the third option is that the confidence interval straddles 0 and is on both sides of 0. If it's on this side of 0, that tells me that mu1 is bigger than mu2. If it's on this side of 0, it tells me that mu1 is less than mu2. So it's too close to call if the confidence interval is on both sides of 0. And if that were to have happened, we would have said, because the confidence interval contains both positive and negative values, we cannot conclude whether the average fat content of healthy snack is higher than overland trail bars. Okay. Does that make sense? I hope so. So finish up the activity, do examples 3 and 4, snap a pic or do a scan and submit them, and then work on the homework.